Hey guys, welcome back with the continuation of alcohols. We were progressing in this topic, and I have told you that oxidation of alcohol will give you respective carboxylic acid. It can be pronounced as carboxylic acid or carboxylic acid, both are considered correct equivalently. Okay, so right now there are two strong oxidizing agents. The strongest one is KMnO4 called potassium manganate, whereas the other is called as potassium dichromate, formula K2Cr2O7. You need to know the color changes. Examiner is asking about the color change. He can ask this thing that how a student can get an idea that an alcohol is no more there because the color of KMnO4 is changed from purple to colorless because the color of K2Cr2O7 is changed from orange to green. So these are the identifications to tell you that acid is formed. Okay, and I have told you yesterday that alcohols are considered as reducing agents. Okay, right now I would like to make the practice for the conversion of the alcohols into the respective carboxylic acids. For example, this is C2H5OH. I have told you that whenever there are two carbon atoms, it is called eth, and whenever there is OH, it is called ol. So the compound name is either ethanol or ethyl alcohol, or it is called as eth-1-ol. What is the meaning of at that one dash oh, look at here right now. So this is oh, this is how we are going to write down the structural formula, the displayed formula for the for this alcohol called ethyl alcohol. Guys, this is the exactly the 100% displayed formula for this. Guys, I would like to tell you that in one of the past paper question, examiner is writing that this is the displayed formula of ethyl alcohol, and he has made this and then this. Okay, so a student who will neglect this bond, will make a mistake. This is not the displayed formula because the O and H bond is not present. Okay, O and H bond is not present. That's why we have to say this thing that this one is not the displayed formula. This is the displayed formula in which all the bonds are shown. So that's why please be careful while selecting your answer for the MCQ paper. So this is not the displayed formula. Okay. So I was telling you that if, for example, we will have ethanol that is called as C2H5OH, and then it is going to convert itself into, you may say this thing, you may write this as well. What is this? This is called as the atomic oxygen, and how it is there right now. You should know this thing that acidified KMnO4 or acidified K2Cr2O7 is a situation, is a reactant, you may say, is a reagent which is changing alcohol into the respective carboxylic acid. So these oxidizing agents are producing this atomic oxygen. Okay, acidified K2Cr2O7 or KMnO4, KMnO4. All right. Okay. Now, guys, what will be the product? As this is ethyl alcohol, so hence it is going to produce ethanoic acid. Okay, so this is the formula for ethanoic acid. How it is ethanoic acid? As it has two carbon atoms, so it is called eth, and it has C double bond OOH. This story I am going to teach you in detail when I will teach you the topic of carboxylic acids. So right now I'm just telling you that it is ethanol, and it is giving you what? Ethanoic acid. Ethanoic acid. Okay, now before moving ahead, I would like to give you one more example, and that is of one carbon. And okay, we can write like this: C4. If it is C4H9OH, so it is just telling you as it has four carbon atoms, so it will be called as but. So an OH is there as well, so butan dash one dash ol, or butyl alcohol or butanol, and we are going to convert it into what? Butanoic acid. Okay, so it will be like this. The formula will be C double bond OOH, and I am going to tell you about the formula making for ethanoic acid, for propanoic acid, for carboxylic acid. I will tell you how we can write this thing. You can see this thing that there are four carbon atoms in case of ethanol, in case of four carbons in case of butanol, and four carbons are there in case of butanoic acid. So these are the four carbons. I would like to erase it so that I may be able to write it more appropriately, clearly, so that you people may have no problem. So look at here right now. So these are the four carbon atoms, and this is the fourth. Okay, so it means that two carbon atom alcohol is going to make two carbon atom carboxylic acid. A three carbon atom alcohol is going to make three carbon atom carboxylic acid. Okay, so this is the basic concept about the oxidation of alcohols. Now I am going to take you to the next concept, which is called as reduction of alcohol. Okay, so let me go on to the next page. Here I am telling you that this is alkene. For example, this is alkene and this is alcohol and this is carboxylic acid. Carboxylic acid. All right, so let me inform you very clearly that here it is formed by oxidation. Okay, and oxidation of alcohol is giving you this, whereas reduction of alcohol is giving you alkene. Okay, so guys, reduction of alkene is, I'm just making a star with this as well. Reduction of alkene is not part of your syllabus directly, but I have told you earlier as well that it will be taught to you in detail in your AS level. Right now I am not teaching you AS level, but I am just telling you that if oxidation of something that is alcohol is changing it into carboxylic acid, then what will be the product if reduction will occur. Okay, so reduction will remove the oxygen content of alcohol. Okay, so you may understand this. And what is the reducing agent? All right, there are certain reducing agent. You may say hydrogen is a reducing agent, but it is comparatively a weaker reducing agent. You may add Ki as a reducing agent. All right, and for example, we may add sodium borohydride. It is quite stronger type of reducing agent that will be not needed, for example. So but remember this thing that for if we have C2H5OH, it is an alcohol of two carbon atoms. So after reduction, what it is going to make, it is going to make C2H6. Okay, it is going to make C2H6. So a two carbon alcohol is going to make two carbon alkene. A three carbon alcohol is going to make a three carbon alkene. Okay, so this is how we are going to make the product regarding reduction and oxidation of alcohol. If now I am taking you to the next page regarding preparation of alcohol, so I have told you the properties of alcohol, which is oxidizing and reduction. Okay, no, one thing is left, and that is called as combustion. I would know, I guess, yes, combustion is done and oxidation and reduction is done as well. Oh, great. So right now I'm going to take you to the preparation of alcohol. Guys, let me inform you very clearly that preparation of alcohol is very, very important. Why it is so? Because alcohol is used in many of the beverages. Alcohol is used as a solvent for the pharmaceutical industry. Alcohol is used as a base for many of the cosmetic industries. So remember this thing that alcohol has lots of diverse uses. That's why alcohol is really very important product industrially. So examiner is very much interested in alcohols. Right now I am just telling you that alcohol preparation is by two ways. Okay, alcohol preparation. Okay, now guys, let me take you to the first point, and that is called as catalytic addition addition of steam to an alkene will give you an alcohol. Okay, the next is fermentation. Okay, fermentation. Okay, so these are the two methods through which fermentation, it's E. All right, fermentation. So these are the two methods by which an alcohol can be prepared. All right, so now you can see this thing that first of all we are going to check this catalytic thingy. Okay, so how this catalytic addition of steam is going to make an alkene. Okay, this is the same topic, guys, which we have done in case of alkene when we were adding steam across the double bond of an alkene. Okay, let's see. For example, it is a two carbon atom chain, and it is an alkene, and it has two hydrogens on one side and two hydrogens on the other side. Okay, and we are going to add H2O. Remember this thing, it is a gas here because it is a steam. But don't forget this thing that what will be the conditions. H3PO4 is the catalyst for this, and 300 degrees Celsius temperature will be used for this, whereas 60 atmospheric pressure will be used for this. Guys, remember this thing that conditions of the reaction should be on that arrow which is going to make the product. Okay, as it is an alkene, and we know this thing that water has two parts, one of them is H and the other is OH. So across the double bond of this alkene, one of the carbon is going to receive H, whereas the other carbon is going to receive OH. This is your choice at this stage of O levels and IGCSE, that with which carbon you are going to attach hydrogen and with which carbon you are going to attach OH. So right now, I am just telling you that, for example, if you are writing this is C, this is H2, and this is C, this is H2, what is the change? It is just changing the double bond into the single bond. Remaining hydrogen atoms will be remain as it is. So one of the carbon is going to attach with H, whereas the other is going to attach with OH. So this is now, it is a shift. It is a transformation of an alkene to the respective alcohol. So we can say this thing that what is the name for this compound? H-1-ene, or it is also called as ethene. Okay, but this, the top one, is the more perfect, more accurate, more appropriate name for this. And what is this? It is called as H dash one dash ol, or it is called as ethyl alcohol or ethanol. All right, all these names are appropriate. Okay, but at dash one dash ol is a very systematic name, so it is just telling you that it is a two carbon atom chain, and at position number one, OH group is attached. Okay, right now, I'm going to take you to another example for this. So it is C double bond C, and it is a four carbon atom chain. OMG, yes. So right now it is H2 here, it is H here, it is H2 here, and it is H3 here. When we are going to add steam across the double bond, what will happen? Remain same four carbon atom chain will be there. The double bond will be shifted into single bond, and it is like this, and this is H2 here and H3 here. Remember this thing, all remaining carbon atoms and hydrogen atoms will be remain intact in the same order, in the same position, in the same way. So right now it is hydrogen here and hydroxide over OH thingy is over there. Okay. So this is up to you perfectly, that how you are going to make a bond, how you are going to attach them, how you are going to look into the thing, that in which way they are going to make this alkene thing into an alcohol. But guys, let me inform you very clearly. I'm taking the idea that this is your choice. This is your choice to make H and OH, at which carbon atom you are going to select H and OH. That why I'm telling you this, there is a reason behind that. When you people will be in AS level, there will be a rule which you need to follow, that which of the carbon is going to attach with OH and which of the carbon is going to attach with H. Right now, those students who are interested in listening that rule, but let me inform you very clearly before telling you the rule, that it is not part of your syllabus for IGCSEs and for GCEs currently, but it will be taught to you when we will teach you organic chemistry at AS level for alcohol. Okay. For the addition of alkene, you may say. All right, guys, let me inform you that there is one rule called as Markovnikov rule. I'm writing the name Markovnikov rule. Okay, Markovnikov's rule. Okay, what Markovnikov's rule is saying? According to this rule, basically, water has two parts. One of them is hydrogen, whereas the other is OH. Okay, so hydrogen part of water will go to that carbon of an alkene which has already greater number of hydrogens. Okay, so this is the rule. This is the rule which is telling you. I'm repeating, hydrogen part of water will go to that alkene, will go to that double bonded carbon atom which has more number of hydrogen atoms. Let's have a look on this. Look at this, these two carbon atoms. So one carbon atom has more number of hydrogen, whereas other has lesser number of hydrogen. So according to the Markovnikov rule, this carbon atom should receive hydrogen of water, whereas this carbon atom of double bond should receive OH of water. Okay, but as I have written here. Okay, but if you are going to write OH over here and H over here, at your level, both of these will be considered as equally correct. So please make sure about these things. This is how we are going to draw the structures. So so that you people have a clear idea that how to make this and how to implement this. But better, let me inform you again and again that as far as you are not going to make up practice after watching these videos, as far as you are not going to check the questions from the past papers, things will be remain in a problem. Don't worry, I will solve the past paper as well on the YouTube videos. But on the parallel level, all of you should try the past papers as soon as possible. All the best to all of you. In the next class, inshallah, we are going to start the topic of fermentation. Then things will become much clearer about the alcohols. Okay, so this was the first method for the preparation of alcohols, which we are done with. In the second method, which is related to the fermentation, that we are going to do in the next video. Thank you very much. Take care of yourself.